Welcome to part 2 of our limits at infinity. I have a new example here. We want to find the horizontal asymptotes of the graph of the function f of x is equal to the square root of 2x squared plus 1 divided by 3x minus 5. And you could see that graph in the upper right-hand corner. So we kind of already have the answer there, but we kind of need to get to that answer. So please bear with me. So we're going to take the limit of this. The first time that we're going to do this is by taking the limit as x approaches positive infinity of this function. So the square root of 2x squared plus 1 divided by 3x minus 5. So now when we divide both the numerator and denominator by x, we have a couple of things going on. So let me write that up here. We know that for values of x greater than 0, right, since we're approaching positive infinity, these are going to be positive numbers. We could rewrite x as the square root of x squared, which is useful for the numerator of this. So this is going to be the limit as x approaches infinity of, for this numerator, combining that with that division by x. This is the square root of 2x squared plus 1 divided by x squared. This whole thing divided by 3x minus 5 divided by x. And we can slightly, unfortunately, rewrite this as the limit as x approaches infinity of. This will be the square root of 2 plus 1 over x squared. Divide all that divided by 3 minus 5 over x. Oh, and we divide it by x because the highest power of x in the denominator is 1. So just x. So evaluating this, we can evaluate them based on the parts, so numerator and denominator, and we can then separate it into each of the parts. Based on those lovely limit rules, we could write the square root of the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x squared. We're going to divide that whole thing by the limit as x approaches infinity of 3 minus 5 times the limit as x approaches infinity of 1 over x. So from what we have, this would be the square root of 2 plus 0 divided by 3 minus 5 times 0, so just 0. This is the square root of 2 over 3, which is our first pink asymptote here on top. To get the bottom one, let me very quickly section this off. I also need to make a second note. This is for values of x less than 0. That means while we have values of x greater than 0, we could rewrite that x as the square root of x squared. For values of x less than 0, we have here negative x. We could express that as the absolute value of x by taking the absolute value of negative x. This gives us, now we could write the square root of x squared. And we could slightly manipulate that, right? To be more closer to this as being that x is equal to the negative square root of x squared, which would then be used in this next limit calculation. So this is the second one, the limit as x approaches negative infinity. This will be of the square root of 2x squared plus 1 divided by 3x minus 5. Dividing by the x like we did in the first one produces pretty much the same result, right? Since we're able to then move the x squared underneath the radical and whatnot. So the only slight difference, though, is when we get to this step. So it'll be the limit as x approaches negative infinity of the negative square root of 2 plus, well, when I say this, I meant down to this, since it's just a small change on it. Negative square root of 2 plus the limit as x approaches negative infinity of 1 over x squared. Divided by, this would be 3 minus 5 times the limit as x approaches negative infinity of 1 over x. All right, so the only difference is we have a negative in front of it due to the values of x being negative, or getting larger in the negative direction. This simplifies to just being negative square root of 2 over 3. So our asymptotes are just y is equal to positive and negative square root of 2 divided by 3. So when we do these limits at infinity, when we have, well, I should say infinite limits at infinity, when we have the limit as x approaches infinity of f of x is equal to infinity, this means the values of f of x become large as x becomes large. Likewise, based on, slight differences, we also have the same thing being true for the limit as x approaches negative infinity of f of x is equal to infinity. The limit as x approaches infinity of f of x is equal to negative infinity. And the limit as x approaches negative infinity of f of x is equal to negative infinity. So likewise, we have this going on. We're going to find the limit as x approaches infinity of x cubed and the limit as x approaches negative infinity of x cubed. So to start with the limit as x approaches infinity of x cubed, we could see it going on here in the graph I have here in the upper right. But if we start putting in values, positive values, large positive values into this function, we could see that, 10 cubed, 100 cubed, 1,000 cubed, we start getting big. So the function continuously increases, doesn't approach anything. So that's equal to positive infinity. Likewise, we could also see this on the graph. The limit as x approaches negative infinity of x cubed, we could see that decreasing here, and we could increase x negatively to get the same phenomenon. We have negative 10 cubed, negative 100 cubed, negative 1,000 cubed. It starts to increase, the values increase negatively. So this is negative infinity. That's part 2 of this limits at infinity. Be on the lookout for the third part, and let me know if you have any questions or concerns. Thank you.